Okay. So in this video, we are going to see the Python implementation of t-test. How can we do it? How are we going to achieve it using Python? Uh, all the types of t-test. Probably in this particular video, I'll see how to do one sample t-test and two sample t-tests. Let's see. Uh, just to give you a heads on to what one sample t-test is, it is basically what t-test is. Let's start by what t-test is. T-test is basically when you try to see the mean or compare the mean between two groups or a group and a value. So when you try to compare the mean between a group and a particular value or mean between two particular groups, this is what t-test is. So in this scenario, we are comparing mean between two groups. In this particular scenario, we are comparing mean with a value. Let's start. So first, let's see what one sample t-test is. Basically, one sample t-test. In one sample t-test, we have a column or a group of numbers or a sample, and what we try to do is we try to compare the mean with a value. And that value can be, let's suppose, to give you an example, let's suppose this is a mean of a students in class, mean of age of the students in the class, and we are comparing it with a value which is mean of the whole country's height. Okay, so comparing the height of the students in class, the mean of the height of students in the class with the value which is equal to mean of the whole country's height. Okay, whole country's height's mean value, comparing it with this sample, and this sample is basically height of all the students in a class. So let's see. To go ahead with, we have 3 to 4 steps in structuring a t-test. First step is to formulate the hypothesis. So in first step, what we try to do is we will try to formulate a null hypothesis, which is basically that there is no significant difference between the mean of the two groups or mean between a group and a value. There is no difference in the mean. Okay, this is our null hypothesis. Now I also need an alternative hypothesis, which is basically there is a significant difference. So here what I try to do is somehow I figure out what null hypothesis is and what an alternative hypothesis is. Null hypothesis basically in t-test tells me that there is no difference. There is no difference. Alternative hypothesis tells me there is a significant difference. There's a difference which is quite visible. There is a significant difference. Second, what I do is I select a significance level. I select a significance level, which is also called as alpha. And what I try to do is I try to, come up with some alpha value, and t-test will give me a probability. And if that probability is less than alpha or greater than alpha, that will decide whether I'm accepting my null hypothesis or am I accepting my alternative hypothesis. So the second step is deciding what your alpha should be. Shortly, we will see in the Python implementation, but this is what we are doing. Next, third step, what we try to do is we calculate t statistics. T-test gives me two things, a probability value and a t-statistic value. So here I will calculate t-statistics. Cool. I'll calculate t-statistics. Using appropriate t-test formula, I'll calculate t-statistics, which will measure the difference between the means of the group and the variation within the groups. Okay. Now I'll determine the p-value. Okay. After I have my t-statistics, on basis of my t-statistics, I'll determine the p-value, which is basically my probability. Okay, I'll have my p-value. To calculate the p-value, which represents basically a probability of obtaining a t-statistics as an extreme. Okay, so what I do is I kind of assume that null hypothesis is true. Initially, I will assume my null hypothesis is true, and now while making a decision, when I get a p-value on basis of this t statistics, I'll somehow get a p-value, and when I get a p-value, I'll compare it with a significance level. What is my significance level? I'll just change my ink. I'll compare it with my alpha. Okay, I'll compare it with my alpha. I have a probability value and I'll compare it with my alpha. Now, mostly the value of alpha which is chosen widely or which is accepted widely is 0.05. It is 0.05, which is basically 5%, which is basically 5%. So the last step, the final step, which is basically making a decision, is you kind of compare your p-value to the alpha, which is your significance value. If the p-value is less than your alpha, you reject the null hypothesis. Your p-value is less than, if your p-value is less than alpha, you reject the null hypothesis, which is you go with your alternative hypothesis. Okay. And conclude that there is a significant difference, which is our alternative hypothesis. Our alternative hypothesis is saying that there is a significant difference. So if p-value is less than alpha, I'll go with my alternative hypothesis. If my p-value is greater than alpha, I'll go with null hypothesis. What is my null hypothesis? My null hypothesis is basically there is no difference. There is no significant difference. So that's it. If p-value is greater than significant value or your alpha, you will fail to reject your null hypothesis and conclude that there is no significant difference. Okay, you can't reject your null hypothesis. Let's see the Python implementation. This is a single t-test or one sample t-test. And basically what we are trying to do is you will be using a library called as SciPy. Okay, in SciPy, there's a module called as stats. Okay, in stats, there is one sample t-test. And let's say this is your score of a student in class. And this is average score of students in whole university. Okay, now you are comparing if there is a difference between this class and the whole mean. Okay, we are comparing it, that is there a difference, is there a significant difference between mean of this whole class of students who have obtained this marks and mean value of all the students in university who have obtained some marks, so mean value of that mark is 70. Now what I try to do is, it is as simple as in stats there is a function called as, in stats module there is a function called as t-test underscore one sample, t-test underscore one sample. And this is what you pass a student score and mean value. Okay, you pass this array, which is basically scores of all the students and your mean value. You will get a t-stat. It will return two things, t-stat and p-value. As I told you, mostly the value which is chosen for alpha is 0.05 or 5%. What we will try to do is, if p-value is less than alpha, if our probability, p-value is basically a probability is less than alpha, I will reject the null hypothesis. I'll go with alternative hypothesis. Okay, I'll go with alternative hypothesis. Let's write with alternative hypothesis. Else I will accept it. I'll accept the null hypothesis, which is basically there is no difference between mu and student score. Mu is your uh, mean of scores of all the students in this university, and student score is basically scores of all the students in a particular class. Okay. So my p-value is 0.047. My p-value is 0.047, which basically means if my p-value is less than alpha, if my p-value is less than alpha, I am basically rejecting my null hypothesis. What was my null hypothesis? That there is a significant difference. So if p-value is less than significant value or alpha, I will reject it. I will reject the null hypothesis. Okay. I am rejecting the null hypothesis. Moving on, let's see what two sample t-test is. We will see it on iris dataset. This is what your iris dataset looks like. It has sepal length, sepal width, petal width. Now what I'm trying to do is, first there is this setosa, which is only setosa column, only species with setosa. Okay. Then there is a data frame with species only is equal to versicolor. Now what I'm trying to do is, I'm trying to, in two sample t-test, what we do is, we compare mean of two groups. We compare mean of two groups. In two sample t-test, we compare mean of two groups, which is, the first group is setosa, second group is versicolor. Now I'm comparing mean. How do I compare the mean? First, what I'll do is, I'll again import a module called as stats from SciPy, and in stats module, I have this function, which is basically my two sample t-test, individual t-test, and it takes two individual groups. Okay, so it will calculate by itself all the mean, standard deviation, and dividing by n, which we discussed in previous video. So it will do it itself, and again it will give me two values, p value and t stats. Again, I'm saying if my p value is less than alpha, which is again 0.05 in this case, you can change it according to your data set, but widely accepted is 0.05. Again, this is the thing. If my p value is less than alpha, I'm rejecting the null hypothesis, which is that there is significant difference between the petal length of two groups. That there is significant difference between petal length of two groups. In this scenario, there is a significant difference. Okay, so I'm rejecting the null hypothesis. So if you see, if I try to print my p value, it should be less than 0.05. I'm printing my p value. My p value is, if you see, e to the power minus 62, which is 10 to the power minus 62 into 5.4. Okay, so basically p value is less than 0.05. And that's why if my p value is less than my alpha, I will reject null hypothesis. Okay, that's it for this video. In next video, let's see some other test. Thank you.